Hello, I welcome you all. The problem reads, the 8 kg sack slides down the smooth ramp if it has a speed of 1.5 meters per second when y is equal to 0.2 meters. Determine the normal reaction the ramp exerts on the sack and the rate of increase in the speed of the sack at this instant. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. Right, so let's write down what we have. So we have y there, y equal to 0.2e to the x, okay? And we've been told that this sack slides down the smooth ramp, and by smooth we mean no friction. So if the speed is 1.5 meters when y is equal to 0.2, so we'll say at y is equal to 0.2, then if we write this, so that we find what would be the value of x. So 0.2 equal to 0.2 ax. Okay, we divide both sides by 0.2. Then we'll have a 1 equal to e to the x. Then we can lean on both sides. Okay. When we do this, then this just becomes lean 1 is 0. Then this is just going to be equal to x goes the other side. So this is like this. So x is equal to 0 at y equal to 0.2. Alright, let's draw the free body diagram now. I'll get this sack. Okay, and then place it here. Just tilt it a little bit. This is the point where we have 0. Okay, somewhere there. Right. Just a little bit. Okay, this is okay. I think so. Alright, so there we go. Okay, so that is where it is going to be. So let's draw the free body diagram. So we have, let's say, the weight of this sack acting through the center of gravity like so. And we do have the normal force. The normal force is going to be a bit inclined like so, right? And then we do have components of this particular force, the weight. We have one component like so, yeah, something like so, and another component, okay, in that direction like so. Okay, and then we also need to find there we go, the angle with this tangential point. So we need to find the angle. Alright, so there we go. So there is this angle there that we need to calculate. So this angle here, we are going to call it theta. Okay, so this angle, this one here becomes 90 minus theta, therefore this is theta. So this becomes theta. let's label this. This is the weight, which is just equal to mg, and then this one becomes just w cos theta, this one w sine theta, and this is the normal force. All right, so let's say we do have coordinates. So we do have coordinates along this direction like so, which I'm calling my t, and I do have another coordinate in this direction that I'm calling my n. Normal and tangential coordinates. And the kinetic diagram will say motion in this direction like so, and motion in this direction like so. Alright, so this is our MAT, this is our MAN. Right, so at this point, of course, we know to say our x is equal to 0. So we are saying this is, let me just also draw this. So let's say this point here. Okay, so let me just dot this. I just dot this up to there like so. So this one is, we are saying y is equal to 0.2. Okay, and this point here is our 0, 0. Okay, all right. So with this information, we can go ahead. We begin to work. We can go ahead to determine the normal reaction, the ramp exerts on the sac, and the rate of increase, which is the acceleration. So let me start with a t. So I'll say apply the equations of motion. Summation of forces, the t axis is just equal to mat. What do we have there? We have sine theta is equal to mat, and therefore our at will just be equal to mg sine theta divided by m. Okay, and this is just equal to g sine theta. So we found our acceleration. Let me write this once more again. You don't have to do this, just me. I think looks like a bit tilted. Maybe I'll do something like this. Okay, all right. So we said this one is w, this one is w, which is the weight, sine theta. So we have found the acceleration, and once we find the acceleration, I mean, this is what they're asking us to find, right? We need to find the angle, right? We need to find the angle. So in finding the angle, we need to take the derivatives of y. So we'll say y prime is just equal to 0.2. Derivative of e to the x just remains e to the x. Let me do in advance y double prime for the sake of the radius of curvature. This still remains 0.2 e to the x. There's no change. So we'll say y prime, we'll say tan theta is equal to y prime, which is equal to 0.2 ex. Okay, so y prime at x equal to 0 is just equal to 0.2. Therefore, our tan theta is going to be equal to 0.2. Then theta is just equal to, making theta subject to formula. So we'll say tan inverse of 0.2. This gives us 11.31 degrees. So found the angle. We have found the angle. Once we have this angle, then we can move on. Let's now find 80. So 80 we said is equal to G sine theta. Therefore, our 80 will just be equal to G, which is 9.81 sine 11.31. Therefore, 80 will be equal to 9.81 sine 11.31. So this gives us a 1.92 meters per second square, and it is in this direction. Something like that. Maybe it's too tilted, a little bit up, something like that. So 9.81 sine 11.31, 1.92. Let's find the normal force. We are going to take the summation of the equation of equilibrium in the n-axis. So say summation of forces in the n. This is just going to be equal to MAN. Going up in our reference, AN is just B squared divided by rho. What do we have in that direction? We have N minus W cos theta, and this is just equal to MV squared divided by rho. So let's find rho. Rho, we are going to use the formula for the radius of curvature, because this surface is defined by this particular function y is equal to 0.2 e to the power x. So rho is 1 plus y prime squared, and then all this to the power 1.5 or 3 over 2 divided by y double prime, and this is just equal to 1 plus y prime at x equal to 0. We found this to be 0.2. Okay, we found this to be 0.2. So let me just show this here down. Y prime at x equal to 0 is 0.2, and y double prime at x equal to 0 is also 0.2. Therefore, our rho will just be equal to 1 plus 0.2 squared, all this to the power 1.5 divided by 0.2, and this is just equal to, that's 1.2 squared to the power 1.5 divided by 0.2. So this gives us 5. This gives us a 5.30 meters. Right, 1 plus 0.2 there, so to the power 1.5 divided by 0.2, 5.30. So once we have rho, we can write that to say n is just equal to, can factor out the m like so, v squared divided by rho plus g cos theta. Therefore, my n there just becomes equal to 8 kg V we said is our V squared at that point is just, our V is 1.5 squared and our rho is 5.30. Our G is 9.81 cos theta, which is just 11.31 degrees. Then N itself will just be equal to 1.5 squared divided by 5.3 plus 9.81 cos 11.31 and everything times 8. So N becomes 80.35 newtons, and this is going in that direction like so. Right, let me again calculate it. 1.5 squared divided by 5.3 plus 9.81 cos 11.31, everything times 8. Okay, I guess this is really about it. We found the acceleration. We've also found the normal force. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.